Okay, 12 and 13 were two other problems that you wanted some help with, and these are both projectile motion problems. And so you've got the guys playing baseball out here, and this point here, this is your point of reference right here. Let me use the pen. That's your point of reference for that. That's your origin, if you will, for both X and Y. And so he's throwing it horizontally, so that means that your initial velocity is going to be in the X direction only. There's no vertical component with the initial velocity. And then we're looking to see, let me back up. It's 12 meters is the range that we're looking at. So that's the X distance that the ball travels before this guy catches it. So let's look at the questions that we have here. Let's see, so we know the initial velocity is 35 meters per second, and we know the distance is 12 meters. What is the speed of the ball just before the first baseman catches it? So let me get my information here that I've worked out. Okay. So here's the tools that you'll need to use. And with projectile motion and two-dimensional motion, there's several equations that you refer to a whole lot. And these are among those. So here's your, well, you can look at them there. But these are important equations. And in fact, I found a website that I want to send you. Let's see. I found several here that I think you'll find useful. Oops, I've got some reflection there. Let's see. Yeah. Now this is where I got some of the equations from. This is a really good website. Got some good information on it, and I'll send you the link to that. So anyway, these are the equations you'll be using. Let me just get this straightened up here. Okay, so given that the ball is thrown horizontally, again, like I mentioned, initial velocity equals initial X direction, which is 35 meters per second, and a principle that you'll need to know is that velocity is constant. So that means that all along the trajectory of this, in other words, over this whole path here, Vx, the velocity in the X direction, will be constant. So important to note for projectile motion. So that's why we know that all three of these in this particular case are all equal to 35 meters per second. And then again, the range, or X, is 12 meters. And so then we've got the question here, let's see. What is the speed of the ball just before the first baseman catches it? All right. So we're looking for the final velocity, and note that final velocity is sort of a resultant, and we need to get the y and x components of that. Okay. All right. So the solution is we want final velocity. We need the final velocity in the y and x, those components of the final velocity. We know that for projectile motion, Vx is constant, as we mentioned earlier. Therefore, Vx initial is going to equal Vx final, which is 35 meters per second. So we've got that number. We can get the final velocity in the y direction from this equation, because this comes from our toolbox right here. Okay. So velocity in the y direction at whatever point equals the initial velocity in the y direction minus g times change of time. It is given that the initial velocity in the y direction is 0 because the ball was thrown horizontally. We know g, and we need change of time. Okay, so we look at our tools again, and we pull up this equation. We know x, which is 12 meters. We know initial x, which is 0. We know the initial velocity, which is 35 meters per second. And we're going to solve for change in time. So delta t equal, if we rearrange this equation, all right, this is going to 0, so this is all that remains. So x divided by initial velocity in x direction, we have these numbers, and it comes out to 0.343 second. And then from the previous page, we also have this from the toolbox, and this will allow us to get Vy, or the final velocity. We know that the initial was 0, we know gravity, and now we know the time. And so this gives us the final velocity in the y direction. I should have put an F there. Is 3.36 meters per second. And so the final velocity, which is the resultant, which is why I'm using VR here, equals this is Pythagorean theorem, these two squared and then the square root. So we plug those in, 35, that's the x direction, and then the y direction is 3.36, and that gives us, and the square root of that gives us 35.16 meters per second. And so that solves, I think that's the answer they were looking for the velocity before the baseball or the catcher catches that ball. And then we'll continue more of this in the next video.